Hi there, welcome to 8.4. This section is all about graphing linear equations. So you guys will have drawn some line graphs before, so this, some of this should be a bit of a recap of that. Basically, to graph an equation, it's best to start with something called a table of values. And table of values just allows us to put in a bunch of values and see what results we get, and then that will give us a set of data points. When we have those data points, we can plot them on a coordinate grid, which basically just means to figure out where they are and draw the points on the grid, and then we can connect the line. So the question we're looking at here, we want to plot a graph of this equation right here. What does that equation look like if we plot it on a grid? So y is equal to 2x plus 3. Now, first thing we're going to do is our table of values, and this is what our table of values looks like over here. Basically, we have a set of x values, and then we're going to find out what is the corresponding y values that go along with that. So you can choose any x values you want, but it's usually a good idea to choose some that are pretty manageable and easy to work with. So, for example, maybe numbers like 2, 1, and 0, those are pretty straightforward. You want to consider that because we're talking about an xy axis, we can go into the negative range as well. So maybe we'll include some negative numbers like -1 and -2. So the question becomes, if I take a 2, if my x is equal to 2, and I place it into this equation, what happens to that equation? So we're going to just do a quick calculation here, and we'll do it for each of them. So the question is, if y is equal to 2x plus 3, what happens when I take this 2 and substitute it in here for my x value? So I can just go ahead and write this as y is equal to 2 times 2 plus 3, which 2 times 2 is 4, plus 3 is equal to 7. So I can take this 7 and place it up here in my table of values. I know that when x is equal to 2, then y must be equal to 7. So I'm going to continue to do this for each of these individual points and just see what I end up getting. So for example, what happens when x is equal to 1? So I would get y is equal to 2 times 1 plus 3. 2 times 1 plus 3 is 5. So I'll place that number up here in my table of values as well. This must be 5. Y is equal to 2 times 0 plus 3. 2 times 0 is 0, plus 3 is 3. And so I can place that in my table of values. We're going to continue on with our negative numbers. So y is equal to 2 times -1 plus 3. 2 times -1 is -2 plus 3. And you'll remember from earlier when we did integers, -2 plus +3 ends up being +1. And lastly, y is equal to 2 times -2 plus 3. 2 times -2 is -4 plus 3. And -4 plus 3 is -1. So we've got a table of values, and this will remind you of some of the work we did on patterns, which is exactly what we see here. We now want to take each of these values and we want to bring them over to the other side here and just plot them on this coordinate grid. So I've got my data points. I know that there's my origin right there. My y-axis is this one. My x-axis is this. And if we just assume that each box is 1 point, then I can plot each of these individual points. So my first point is going to be 2, 7, which will be 2 spaces over, and 1, 2, 3, 4, 5, 6, 7 spaces up. I'm just going to place a little dot there, and that's my point 2, 7. Plot the next point, 1, 5. That's 1 space over, and 1, 2, 3, 4, 5 spaces up. I don't need to write the coordinates for each of these points. I'm just writing it for the first one to give you an idea. Our next point is 0, 3. So on 0 and 3 spaces up. Our next point is -1, so 1 step to the left and 1 step up. And our last point, our last point is -2, and this should be -1. So negative 2 spaces over and -1 space down. Okay, so we can see straight away, when we look at the plots we pointed, that it looks kind of like a straight line, which is good because we're graphing straight lines. So now that we've got them all plotted, all we need to do is use a ruler, use some sort of straight edge, don't just sort of eyeball it, make sure you do a good job, and line up your ruler with all of the points, and then go ahead and draw a straight line, connecting all of the points. Something like this. Now, you'll notice a couple things. Number one, I don't stop my line when I get to my last data point. I continue it on in both directions. In actual fact, because this is a line, it goes forever in both directions. Just because I run out of grid paper, technically this line keeps going. So sometimes what you'll see that people do is they'll draw a little arrow on the end of this line. That means actually this kept going. I just ran out of grid paper, or maybe I just got too lazy to keep drawing it. So down here I'll put an arrow as well. It goes on forever in both of those directions. Okay, that's it for lesson 8.4.